Let's talk about how to do problems like problems I called type 1 in class, exponential equations type 1, where it's like a to the x equals b, where a and b are both integer powers of the same base. A and b are both integer powers of the same number, where a and b are both integer powers of the same base. So I'm talking about problems like number 18 from the homework. 18 from the homework was 1 over 125 to the x plus 2 equals 25 to the 3 minus x. This is that type of problem because these are both powers of 5. 1 over 125 is 5 to the negative 3. 25 is 5 to the 2. I could write both of them as 5 to the something. So that's what I do. That's how I solve it. So I start off the problem with, wrong way, with, it was 1 over 125 to the x plus 2 equals 25 to 3 minus x. I started off by writing both of them as 5 to the something. Their common thing that they're both powers of is 5, so I write them like that. Say 5 to the negative 3 to the x plus 2 equals 5 to the 2 to the 3 minus x. And then I multiply exponents, power to a power, and multiply the powers. Makes 5 to the negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Common mistake would be just to write negative 3x plus 2, or to write, I think that you're supposed to add them, right, like x minus 1. Negative 3 times the whole thing. This side becomes 5 to the 2 times 3 is 6. 2 times negative x is negative 2x. And now what I'm able to do is I'm able to say that negative 3x minus 6 equals 6 minus 2x. The reason I'm allowed to say it, what I'm doing to both sides of your algebra, you kind of do something to both sides to move from one line to the next. What I'm doing to both sides is I'm doing log base 5. I do log base 5 to both sides because log base 5 of 5 to the negative 3x minus 6, that's one of those things where it cancels. Log base 5 of 5 to the, it all cancels out, just makes negative 3x minus 6. The reason it cancels is this says 5 to what power is 5 to the negative 3x minus 6. 5 to what power is 5 to the negative 3x minus 6? 5 to the negative 3x minus 6 is 5 to the negative 3x minus 6. If you don't get what I put in green, that's fine. What you need to know is that 5 to the equals 5 to the, I just can say that the exponents are equal. So, but it's ideal if you get what's in green. Now it's an algebra 1 problem. I solve for x. If I move the negative 3x over here, it turns into a positive x. If I move the 6 over here, it makes negative 12. That's going to be my answer. Negative 12 equals x. If I want to check it, I can plug it back in. Plug in a negative 12 here, it makes to the 10. So this is going to be 5 to the negative 3 to the 10. It's going to be 5 to the negative 30 on this side. If I take negative 12 and I plug in up here, I get 25 to the 3 minus negative 12 is 15. 25 to the 15 is 5 to the 2 to the 15, so it's 5 to the 30. Both sides come out to 5 to the 30. Positive 30. So I'm happy. 5 to the 30 does equal 5 to the 30. Let's do another. By the way, it is super weird making this video with no one here, none of you all here. It's weird to work without your feedback. I like to talk to you and look at your beautiful faces. I'm going to do number 20. Number 20 is this one that says, you can't see that because it's not being shown right now. It says 4 to the x equals 8 to the, on the homework it says chocolate. I'm going to write something besides chocolate. The idea was that you could solve for chocolate. If chocolate's just a number, let's do something a little less silly. It'd be fine if I now wrote vanilla. Let's do like 3x plus 7. I look at 4, I look at 8. It's one of these problems where both of them are powers of the same number. 4 and 8 are both powers of 2, so I'm going to write both of them as powers of 2. 2 to the 2 to the x equals 2 to the 3 to the 3x plus 7. 2 to the 2 is 4, so I just wrote 2 to the 2 instead of 4. 8 is 2 to the 3, so I just wrote 2 to the 3 instead. And now that means that I can write 2 to the 2x equals 2 to the 3 times 3x is 9x, 3 times 7 is 21. And I do the log base 2 to both sides and get 2x equals 9x plus 21. I look at this and I say the fact that 2 is the same on both means that these exponents must also be the same to make them come out to the same number. But behind the scenes what's going on is that I did log base 2, log base 2. That's if I had to choose something to say mathematically, what did I do to both sides? I did log base 2 to both sides. Log base 2 of 2 to the 2x means 2 to what power is 2 to the 2x, so it's just 2x. Or I just recognize that this is one of the situations that cancels. Log base b of b to the power cancels all out, and it's just the power. Or I think about this as an exponent can come down to the front. I could write it as 2x times log base 2 of 2. Log base 2 of 2 is 1, so it's 2x times 1, which is just 2x. So that's why this comes up to 2x. Or I just look at this, and without the orange part, I just say the exponents have to be the same. 2 is the same, so the exponents have to be the same. 2x equals 9, so I subtract 7 over. I just subtract 2 over, get 7x. Subtract that, I get negative 21. If I divide by 7, I get negative 3 equals x, which is pretty cool since I just made up that little thing there. It's nice that it came out to a whole number. Hope this helps.